Okay, folks, in this video we're going to talk about the uniform distribution. So the uniform distribution is one of two distributions that are continuous distributions that we'll cover in our class. It's actually not that common, a uniform distribution, but it is an easy sort of baby steps into figuring out really what is this whole distribution, continuous distribution probability thing's all about, because it's pretty intuitive and pretty easy to understand. So a uniform distribution is a random variable is uniformly distributed, and that it means that there is equal chance for the variable to take any value between 2 points. This means there is no most likely point, hence an average measurement does a poor job describing data. All right, so here's an example. The amount of gasoline sold at a service station is uniformly distributed with a minimum of 2,000 gallons and a maximum of 5,000 gallons. All right, so from a graphical standpoint, we're just finding the area of a rectangle. This is important. Area of a rectangle. This is all that we really are trying to figure out. The area of a rectangle. In fact, here's a picture of one. So for a uniform distribution, the probability that x falls between 2 points C and D looks like this. I have some C, some D. I want to know what's the probability. P, the probability it finds between these 2 points, is the width times the height. What is width times height? That's just area, right? Which is, in this case, is D minus C, that's my width, times my height. Then it says right here, height is 1 minus B minus A. So actually, I'm going to show you even a different way to do this. So before I do that, I'm going to come up here and say, oftentimes for uniform distributions, we see them written in shorthand like this. We see a U. This is like a U. U. A is our minimum, and B is our maximum. So A equals the min. B equals the max. Whoops, something like that. That's how it would be written. So we're going to use some shorthand on several of these distributions. If you see something like this, that means you can assume a uniform distribution between A and B. All right. So let's talk about this again. Let's see if we find this idea, this probability that x is between C and D. Well, that's really just this area right under here, C and D. C and D. So for uniform distributions, what we assume is that this whole area, all the possible sample space, from a probabilistic standpoint, equals 1. The probability of something happening between A and B is 1, 100%. There is no chance of something happening smaller than A, and there's no chance of something happening bigger than A. So the chance between A and B is 1, or 100%. In fact, that's how we found the height of this. 1 divided by B minus A. We forced it to equal to 1, right? So if we say B minus A is our width, then we can say, well, if we know that B minus A is our width, times some height, we're going to make that equal to 1. B minus A times some height equals 1. All that's really saying is that this area of this box has to equal 1. So remember, we're dealing with probabilities. This f of x is a probability, or it's a way to think about probabilities. So that's why we force it to equal to 1. So if we think about that, then we can actually solve for this a little bit different. So then we can say, well, the height then just equals 1 over B minus A. I just did some math, right? I just put B minus A over here in height. That's how we got this. That's okay. So that's great. So we could solve for this in that way. There's another way to solve for that. I think it's even easier. I want to find the distance between C and D. I want to find how much this space is over all of it. Is really just think about the numerator and the denominator. Right, that's all probability is. So in this case, the numerator would be the area from D to C. That's the numerator. The denominator would be the difference between B minus A. That will give me the same answer, actually, than this right here. So this is all we're going to do. That will just tell me this area. In fact, we can draw like this. It equals that. That's all. So let's give this a try, and it will make a little bit more sense. All right, so first step, always draw a picture. All right, find the probability the daily sales will fall between 2,500 and 3,000 gallons. All right, so first step, always draw a picture. So I think I left something out. Oh, that's right, I did. So let me tell you what the uniform distribution here is between 2,000 and 5,000. So that what I'm saying is that some X or some Y is roughly uniformly distributed between 2,000 and 5,000. So let's figure that out. So here's 2,000. Here's 5,000. If it's a uniform distribution, then it looks something like this. Equally likely across all possible spaces. The question is asking then, what's the probability of something between 2,500 and 3,000? So it doesn't matter, but I'm not really drawn to scale very good. This is a box right here. All right, this is the area. That's the area we're interested in. So we're actually really concerned about the area of this box as a percentage of the area of the entire box. That gives us the probability. So we could rewrite this as, what's the probability that some X is between 2,500 and 3,000 given a uniform distribution between 2,000 and 5,000. That's how we'd write that, right? So how do we solve this? Well, we can just find the area between 3,000 and 2,500. That's our numerator. 3,000 minus 2,500 divided by the numerator, which is the total square, 5,000 divided by 2,000. Or minus 2,000. Minus 2,000. Which comes to 500 over 3,000, which is 16.6%. So really that means there's a 16.6% chance that we're going to be between, the daily sales will be between 2,500 and 3,000. All right, that's it. That's all you do to find these problems. That's the answer. Let's do one more. What's the probability that a service station will sell at least 4,000 gallons? Whoa, sorry. At least 4,000 gallons. What does at least 4,000 gallons means? This is sometimes the hardest part. Which way does the alligator go? Probability that X is at least some number there, 4,000. What do I put here? This way or this way? At least, that means greater than or equal to. At least means it could at least equal 4,000, right? Given I have a uniform distribution between 2,000 and 5,000. All right, let's draw the picture. Same picture as before. Here's 2,000. Here's 5,000. Let's scroll down just a little bit. 2,000. Here's 5,000. Here's 4,000. Now, which side do I, what do I color here? At least. That means it's 4,000 or more, right? So this is why we draw a picture. We got to draw pictures so we see what we're actually doing here. All right, so what's my numerator? Numerator then is 5,000 minus 4,000. Denominator, 5,000 minus 2,000. This is 1,000. This is 3,000. That's 1/3. 0.333 repeating, all right? 33.3%. That's it. That's all we do with that one. One more. I promise it's the last one. What is the probability the station will sell exactly 2,500 gallons? By the way, this is a trick question. Probability that X equals 2,500 gallons, given I have a uniform distribution between 2,000 and 5,000. Solve it the same way we've done before. Here's 2,000. Here's 5,000. 2,000. 5,000. All right, 2,500 is like right here. And let's shade in what we care about. All right, we care about this right here. That's what we care about. All right, what's our numerator? Numerator is 25,000 minus 25,000. So far, that looks good. Denominator then is 5,000 minus 2,000. This equals 0 over 3,000. which equals 0. Bow, bow, bow. All right, so this is actually the problem we talked about in the last video. There's actually, you can't do this. Theoretically, we cannot say the probability that x equals some one single number if I'm dealing with a uniform distribution, or sorry, if I'm dealing with a continuous distribution, any continuous distribution, because we have to find the area under a curve with a continuous distribution. And there is no area under a single space, right? So instead, I could write something that looks like this. What's the probability that x is between 2,501 and 2,500? I'm allowed to do that, right? In fact, that would be 1 over 3,000. So I can do that. I can find intervals, but I can't just find instantaneous spots. All right, that's it for this guy.